Hey, hello everyone. I hope you're enjoying your week and welcome back to our monthly Tech Talk. My name is Yufa and I'm your host for today. Before we start, I want to thank our sponsor, the Collab Lab. We're run by volunteers. We're dedicated to breaking down barriers, providing early career developers with a supportive space to gain real-world experience by collaborating on project remotely. If you want to learn more about us, please reach out. Next, I'm super excited to introduce our guest speaker today, Carson Gross. Carson is a professor at Montana State University and the sole proprietor of Big Sky Software. And he created a few open source projects like htmx and hyperscript. Welcome, Carson. I'm going to hand over to you so you can share your slides.
Great, thank you. Appreciate that, Yufa. Let me get my right screen up on here. And can everyone see that okay?
Yes.
Yep.
Yes. Okay. So I wanted to give a talk today about decoupling and talk just a little bit about what decoupling is and how it relates to htmx. So first, intro to me if you don't know who I am, which is totally understandable. I'm just a random guy in Montana. I have a company called Big Sky Software, and that company is it's basically a one-person LLC that I use to kind of do open source work and a little bit of consulting with. We've got some software projects, like Yufa said. So htmx.org is definitely the biggest of the bunch, and that's what I'm going to focus on today. There's also hyperscript.org, which is a scripting language for the web, which is kind of a funky little thing, but we probably won't talk too much about that. And then there's a somewhat funny, I don't know, maybe funny, maybe cringe, maybe both, thing at grugbrain.dev, which is about sort of it's me trying to take, as the gray in my beard indicates, I've been programming for a while. And so this is me trying to like communicate to younger people in a humorous way the lessons I've learned about software. And then we also have a book, Hypermedia Systems, that is sort of kind of outlines the big ideas with HTMX and walks through building an application with HTMX, as well as another hypermedia system called Hyperview, which is a mobile hypermedia. So if you're really into hypermedia, then you can take a look at hypermedia.systems. So that's kind of who I am. And I want to talk about what decoupling is and what network architecture is. And what I want to do in particular is contrast how JSON APIs decouple clients and servers and how RESTful systems decouple clients and servers, and then talk about how HTMX fits into that whole sort of like that whole idea. So the first thing if we're going to talk about what different approaches to decoupling, is what is decoupling. And so it's this idea that coupling is how tightly bound two units of software or modules. In Java, for example, we might talk about two classes that have a lot of interconnections between them. They're highly coupled. And the coupling isn't always bad. If two classes are tightly related to one another in the Java world or whatever, then it's not necessarily bad that they have a lot of connections between one another. And so there's this other idea of cohesion, which is the idea that, okay, these things belong together. It probably makes sense that these two things are next. And so, an example might be if you have an abstraction like a vehicle, and then you have specific types of vehicles like cars and trucks. Like it would make sense for those all to be sort of like together and have some interrelationships between one another. Whereas if you had sort of a vehicle and then you had an account, those have less to do with one another. And if there's a lot of interrelationship between those two concepts in your system, maybe that's indicating that you have too much coupling that's going on in your system. Why is, in general, I think most developers on this call probably have a intuitive understanding that decoupling is good. And the reason for that, the obvious one, is that if two things are decoupled from one another, then changes to one hopefully have very few changes to the other. And so you can make changes kind of independently from one another. And then you can build and You can test those things separately, and then you can even reuse them. If you don't have to bring in five different things to use this one thing that you're interested in, that makes it easier to use this one thing. And so, in general, I think most developers sort of they try to strive for decoupled software. Just like everything else in software, there are trade-offs, and so there are some downsides associated with decoupling. And this is very language dependent and conceptual. This is very subjective in many ways, but decoupling can have some downsides. It can introduce a lot of abstraction and complex relationships between parts of your system. So if you've ever worked with like a super complicated dependency injection system, that complicated dependency injection system is there to support decoupling, and maybe that's worth it, but maybe sometimes it isn't. Certainly can introduce performance issues because now you're dealing with abstractions to get sort of between parts of your system. And it can also lead to architecture astronauting, which is, this is particularly bad in the Java world, which is what I'm most familiar with, or where I'm most familiar with this problem, which is when you just have like an incredible explosion in support code to support the decoupling of things, when it would just be so much easier to just have this thing call that thing and call it a day. Another example where maybe there's too much decoupling is the current trend towards microservices, where you have individual services for all sorts of things, and that can be good in some cases, but can also become very unwieldy and unmanageable in others. So decoupling isn't a universal good. It's it's a good thing, but it has to be weighed against other considerations as well. Generally, I think most software developers agree that decoupling is a good thing. And here's a little bit of code where we have sort of an email subsystem. And we have a user model. So this is just, imagine this is in a web application or whatever, and we look up a user via their ID, and then we send a welcome email to that user. And what helps decouple this code in particular is the fact that we're passing in an email first name and last. We're passing in strings to this send to method. And so our welcome email doesn't know about users. It just knows about these strings, which are sort of a universal object. So our welcome email is not tightly bound to users. And what that means is that if we're testing this email subsystem, we don't need to have to know about the users. We don't have to create users. We can just, we can create strings, and, those are sort of base objects in our system. And so these two are decoupled from one another. And that would be in contrast with passing the user into this. Now, I'm not saying it would be bad to pass the user into this. I'm just giving this as an example of sort of like very basic sort of decoupling, where we've decoupled the email subsystem from this user model. So that's great. Unfortunately, sometimes that can lead to code that looks like this, where we have a dependency manager and we look up a service locator, and then we have a service locator which resolves a user finding service, and then we use the user finding service to resolve a user mapper service, and blah, 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 blah. Like, this is the kind of code that I think sometimes can give decoupling a bad name, where people are just like, look, this is way too much junk. What are we doing? Like, we just want to send an email to a user. And so this is the sort of code that if you become too intense about decoupling, you can end up with code that looks like this. And this probably isn't. Again, it totally depends on the context, but I would say this code I would rather work with than this code in general. That's an opinion. It is what it is. But that's kind of like what decoupling is, and those are the approaches you can take to it. The next part of the talk, or the next sort of definition that we need to establish for the talk, is what a network architecture is. Network architecture, unfortunately, means a bunch of different things. Like, you can talk about like the OSI network model and all that stuff. Here, when I use the term network architecture, what I mean is, how does your application how does an application use the network? So we have some sort of a distributed system, and the web is a distributed system. We have clients and servers, and those servers are often, networked together in some sort of cluster and so forth. And so the network architecture that I'm talking about is how we choose to structure the nodes in the network at the application level. I'm not talking about low-level networking stuff here. I choose that term network architecture because that's what Roy Fielding, who's this is a picture of Roy Fielding. That's what he talked about when he wrote a famous his famous dissertation on the architecture of the web. Roy was an initial engineer on the web, and the dissertation he wrote talked about the network architecture of the web as sort of a distributed system. Some general classes of network architectures. The two big ones are client server, which is probably the most popular one. Increasingly popular these days, though, is peer-to-peer, where there's no notion of a client and a server. They're just all peer nodes, and they can communicate with one another via some sort of network protocol. Another axis within the client server architecture, another axis that you can split things on, is thick clients versus thin clients. And so this has sort of been an ongoing battle in the industry for 60, 70 years now, where there are thick clients and there are thin clients. And a thick client is a client that has a lot of logic on the client. And so a classic example of that would be like VB applications that were built in the 1980s, where you launched a VB application and it had all the logic running on your Windows machine or whatever. And it was communicating with a server, maybe with a database or something like that. But it was displaying sort of like it was running a lot of logic on the client. And it was displaying widgets that were very heavy and like often had a lot of like, graphics associated with them and so forth. And in general, the thick client has been, I think, associated more so with rich interactivity. You see that today with like mobile applications are an example typically of a thick client where it's taking advantage of a lot of the local CPU processing power. And I actually built VB applications back in the day. I liked VB. That was fun. Thick clients have advantages, so they can take advantage of the local machine. They, in general, can offer richer interactivity, and there's less burden on the server. These are all advantages, and you see people argue for these advantages today, for example, in favor of mobile applications over maybe progressive web applications. They'll say, oh, you can't, why would I do rendering on the server, for example, rather than just sending data down and letting the client, like all these distributed clients, render them? So these are sort of the advantages associated with it. But this other approach, the thin client, is the idea that rather than having a sophisticated client, we're going to have a pretty basic client. And sort of the original thin client was actually like a physical machine that you plugged into a mainframe, and it was literally a terminal that was plugged into the machine, into a mainframe, and the mainframe was driving all the logic of what was being presented. And in this approach, the server becomes much more prominent. Again, this is sort of a descendant originally of the mainframe terminal setup. But once we had networking, people, today you probably still use terminals when you connect to remote systems, and those are at some level a thin client because the local, you don't take advantage of most of the windowing abilities of your local system. Instead, you're letting the server drive the interactions. Now, thin clients, they typically don't have the same interactivity that thick clients have, but they do have some pretty big advantages. Number one of the biggest ones is that your logic is centralized. So rather than having a bunch of really intelligent nodes that are trying to synchronize with a central node via some sort of data synchronization mechanism, you have one central node that's sort of making the decisions and then streaming the results out to these relatively thin clients. Another aspect of thin clients that's really nice is that they don't need to be updated as much. So if you've ever been through the pain of updating a mobile application in one of the app stores, then like this can be an annoying process. And it's much nicer, for example, with a web app, like you just go to a web page, you get the newest version of that web app, and that's it. There's no install. There's none of this big install clunkiness that you have to deal with thick clients. And then finally, and this sort of relates to the first point, it's easier to synchronize, multiple users sort of contesting for data. It's easier to synchronize if you have a single source of truth on that server. So there are other advantages and disadvantages to both, but that's just to give you a flavor of both. Now, here's a question. is the web or browsers a thick client or a thin client? Are browsers a thick client or a thin client? And I think that's a trick question because I don't think they're either. I think they're a third kind of client. There's no way you can call a browser there's no way you can call a browser a thin client. But on the other hand, the way that they interact with the server is done in a way that's more, in some ways, more closely related to the way thin clients work than the way that thick clients work. And we'll talk about exactly how that is in a second. So I really think, thin client versus thick client when you talk about the web. It doesn't really apply. Instead, what the web really is a RESTful system. And that RESTful system involves a client that's designed to take advantage of the RESTful network architecture. Now, if you're not familiar with REST and your eyes start to glaze when you hear the word REST, I'm sympathetic, but I do want to take a second and talk about what this means. So most people, when they hear the word REST today, they think of a JSON API because that is the way that the industry has been using REST for the last decade and a half, unfortunately. And that's actually incorrect. That's actually incorrect. But we're not going to fix that. But when I talk about REST, I'm talking about the original idea of REST. And what REST was Roy Fielding, again, this guy that I've got up on the screen. This was the description that Roy Fielding came up for the network architecture of the web. And he had a series of constraints that a system had to satisfy in order to be considered RESTful. And so it needed to be client server architecture. So, okay, it had to be stateless, caching, a bunch of stuff. The important one here, in my mind, is the uniform interface. The uniform interface was really the defining characteristic, I think, of the web. And that constraint consisted of 4 additional constraints that you can understand why people kind of their eyes glaze over, but bear with me. So the uniform interface says that you have to have identification of resources. So URLs on the web are the way that we identify resources. You manipulate resources through representations. I have to admit, I don't totally understand what that means. I kind of get what he's getting at, but whatever. The really important one to me is this one, self-descriptive messages. So there's something about the web, the way the web works, where the messages that are sent, particularly from the servers to the clients, they contain self-describing information. So, and what I mean by that is that the web page, when you get a web page, that web page within it captures all of the actions that you can take, all the links that you can click, and all the forms that you can submit in particular. And so it describes what you can do with the system. And that really is, in my mind, the crux of the uniform interface. We'll talk more, I'll contrast it with JSON here in a little bit. The final constraint was Hypermedia is the engine of application state. I've got an essay up on the htmx.org website that you can read my take on this. But I think really I want to focus in on the self-describing messages because I think that's kind of the crux here. And this is a quote from Roy Fielding. So the central feature that distinguishes the REST architectural style from other network-based styles is its emphasis on a uniform interface between components. Implementations are decoupled, so there's that word decoupled, from the services they provide. The trade-off, though, is that the uniform interface degrades efficiency. And so this is very academic language. But what Fielding is effectively saying is because the web uses these self-describing messages, it is a decoupled network architecture. This is a decoupled network architecture. And so that's, in his opinion, and I agree with him, that's what makes the web different and special when it comes to this idea of decoupling. So that's the theory. Let's look at the practice. Here's some HTML. Hopefully everyone on this call is familiar with it. And this is some HTML that represents a contact. It's not very good HTML, but that's fine. And it has an archive. And what do we have here? Well, we've got an email, we've got the status information, and then we've got a link here that presumably goes to a web page that allows you to archive this person, whatever it does. It goes to this URL, loads the new user interface, and you can manipulate that however you want. And what's really crucial to understand, the uniform interface that Fielding was talking about is really jumping out at us right here. This link, when it comes down to us, the browser, and when Fielding is talking about the web, the browser is the client. The web browser is the client, whereas the server is the web server. The browser doesn't know anything about contacts. It doesn't know what a contact is. It doesn't know what archiving is. It doesn't know anything about that. All it knows how to do is render hypermedia. And so it's going to get this link, it's going to render it, and then the user can select those actions. So when he says that the client and the server are decoupled, that's what he's talking about. There's a service being provided here, in particular a contact service, and that service is being handled by a web browser, a client that knows nothing about contacts. So the web browser is decoupled from the concept of contacts in a pretty radical way. And that's something that's kind of crazy about web browsers. If you told someone in 1980 that they would be using a single piece of software to like get their news, pay their taxes, buy a car, check check the results of a test of the doctor and all that stuff, they wouldn't have gotten their head around that. That sounds like a bunch of, if they knew what an application was, that sounds like a bunch of different applications. But because web browsers are decoupled from the services that are being provided by web servers, they're able to do all these things. So this is decoupling in a very significant way. This is what Fielding is talking about when he talks about decoupling. So to show you the power of this decoupling, what if a new action was added to our contact system? So what if we added the ability to send an email to a contact? Well, we would just get a new email when we went, or excuse me, we would just get a new web page when we went to this when it logged into our application next time or clicked on the link or whatever, hit refresh, and we would get a new web page, and inside that new web page there would be a new link. There would be a new link, and that would be rendered, and we could click on it and maybe go figure out how to send an email to our contact. But we've changed the shape. We've added new functionality to the system. Without the client being updated. The client just sees the new functionality, renders the links, and that's it. Because it's all done in terms of this uniform interface of hypermedia. So that again shows this the decoupling that we've achieved here. Okay. Now, I hope I've convinced you, or at least you're somewhat sympathetic to the idea that there is a sort of decoupling that's happening here. But there are a lot of people, I'm sure if this is being watched on YouTube, it'll be in the comments. There's going to be a lot of people that say, what are you talking about? This response is tightly coupled to your web application. This is strongly coupled. This is like there's presentation information in here, and there's this is a web page. I can't reuse this for my mobile application. I can't reuse it. I can't use this for a script like a client or a batch client where I'm trying to scrape this stuff. And they're right at some level. This information is tightly coupled to the service that is being provided. People that are going to be particularly upset about my claim that is decoupled are going to say you should be using JSON. If you want to decouple the client and the server with a web service on the web, rather than returning HTML, you should return JSON because JSON is decoupled. So here's a JSON example of that previous data. So this is the HTML for it. This is the JSON for it. And so many people would say this is decoupled. This very tightly coupled. This is decoupled. And at some level they're correct. At some level they're correct because it's true that this is a more generally useful representation of a contact. Like this could be consumed by a web application that get a fetch against it, for example. This could be used by a mobile client. It could be used by a batch job or whatever. There's a lot of different systems that could consume this information that would have a hard time consuming the HTML. HTML makes it hard for pretty much anything except for a browser, a hypermedia client, to consume it. So the people are right in that sense. And again, we have to go back to this quote. Distributed hypermedia provides a uniform means of accessing service through the embedding of action controls with the presentation of information retrieved from a remote site. So this is a quote from Fielding's dissertation. And what I want to particularly focus on is the embedding of action controls within the presentation of information. The web was designed with coupling between actions and data. Like it's explicitly part of the original design of the web that these two things, the data that we were going to present and then the actions available on that data, are coupled together. They're coupled together. I'm sorry, I raised my hand. I think I put my hand up. So this was sort of part of the initial design of the web. And this is one of the things that has made it hard to reuse the web formats like HTML for general purpose data integrations, is it has this kind of weird mixing of presentation with control data, which, you know, a lot of people would say that's not decoupled. That's not decoupled. And, you know, I think they have a point. At some level, this HTML response is the user interface you want displayed. So it can't really be decoupled from the user interface. We're returning the user interface that we want to reply. But if we want to understand how this kind of decoupling actually works on the web, let's go back to that example that we looked at where we added a new feature. We added the ability to send an email to a contact. When we did that with HTML as a response format using the RESTful network architecture, we just got a new page and we saw this link. Oh, okay, I can click on that and I can send an email to that person. What happens when we add that functionality to a JSON, to a system that's based on this JSON representation? What changes about this JSON? The answer is nothing. The answer is nothing. Nothing changes about this response. And if clients want to take advantage of this new functionality, the clients need to be updated. The clients need to be made aware of the functionality, and then they need to write new code. A new client needs to be deployed in order to take advantage of this new functionality. So in that sense, this API is actually more tightly coupled to the clients. The clients have to be updated when changes are made to this to the functionality that's available for the contacts in a JSON-based system in a way that they don't have to be when you use HTML. And that's showing the ability of HTML to respond to changes in a way that's more flexible than this thick client approach that when you initially look at it, you say, oh, this is more decoupled. Well, in fact, it doesn't handle change as well as the HTML system does, where HTML, the browser being the client, can just see the new HTML and render it, and everything's good. So in some sense, as crazy as it sounds, this is actually more an API that responds with something like this is more coupled to clients that consume it than the HTML is. Okay. So why is that? Well, this approach to decoupling, and it is decoupled in one way, as I've already said. This is decoupling at the application level. So the application is choosing the data format that it's using and saying, okay, I'm just going to return generic contact information. And in with that generic approach comes some decoupling, in that there's no display information or anything like that associated with it. Clients can do whatever they want. The HTML/RESTful approach, that is decoupling a level down. It's decoupling at the network architecture level. And at the application level, it is actually tightly coupled. So the HTML is tightly coupled to your UI because it is your UI. So we've actually, when we're talking about a RESTful system, we're moving that decoupling down a layer to the architecture, the network architecture, the approach that we're taking to building our application. And we're more tightly coupling at the application level. And so this is really the crux. The crux is we saw that when we added functionality to both of these systems. We add this ability to send an email to a contact. Our RESTful system, client doesn't need to be updated. You hit refresh, it sees the new HTML, and it is what it is. It can render that link, and all that behavior can be given to our users without any sort of major update. On the other hand, if we've got, for example, a mobile app that's consuming this API, now we've got to update the mobile client. Now we've got to update our mobile client in order to take advantage of this ability to email, in order to take advantage of that. All right. So that shows you, I hope, or at least gives you a sense of how the uniform interface, this idea of just communicating in terms of this generic HTML, is it less efficient in some ways? Yes. Is it more specific in some ways? Yes. Does it mix control information and display information? Absolutely. That's how the web was designed. Is this a good format for us to use for inter-machine communication? Absolutely not. Absolutely not. But there is this decoupling that comes with this approach that is very useful, and in my opinion, anyways, underappreciated. So cool. So should we use this? Should we use RESTful? Yeah, I mean, I think, should we use a RESTful approach for decoupling? Yeah, I think there's a lot to it. I think it's a good idea, and I'm a big fan of HTML because of it. Does that mean that we should use this format for communicating with like a mobile app that we're building? No, no, it does not mean that. It does not mean that. I think that both approaches have their own use cases. And so for your web application, I recommend, I think depending on what you can get away with from a usability standpoint, I think HTML is a good technology to use for your web applications. And then for other applications that aren't built on top of a hypermedia system like the web, then maybe you could look at JSON, and you could use JSON for communicating with your mobile application, and accept the fact that it's going to be more difficult to deploy changes for something like that, because you have this tighter coupling at the network architecture level than you have on the website. On the website. So that isn't as crazy as it sounds. Sometimes people look at me funny when I say, "Oh, you should just have both of them." You actually get a benefit from having a web API that's HTML driven, and then your other APIs being JSON driven or whatever. And in that, it disentangles those two use cases. So one thing most web developers notice after a few years working on the web is that web apps tend to be very churny. You add lots of features, and then you remove them, you pull them, pull them out, you refactor things, and so forth. One of the great things about the RESTful approach and the HTML-based approach is that you can do all that, and to a first order of approximation, it all just works out because links come, they go, and it's all fine. If you try to do that with a JSON API, if you're constantly adding and removing functionality, if other people are trying to use that same JSON API for other stuff, then it can become very hard on people, because you have to version your JSON API. You have to be careful to be backwards compatible or not, or you forget, or whatever it is. And so by disentangling your web app from your non-web clients, you actually can settle your JSON API can be much more stable, because it's not trying to keep up with all the needs of your web application. And there's actually an essay on exactly that on the htmx website if you're interested in that. Now, why are we using JSON? So I've just made an argument, I hope reasonably compelling, that the RESTful HTML-based version of the web responds really well to changes, and has a lot of advantages associated with it. So why did we abandon it for JSON? And the answer there, I think, is pretty practical, which is that the original model for the web of links and forms is kind of clunky. It's very clunky when compared with single page applications, things you can build with like React and Vue and so forth. And a lot of pressure was put on web apps when mobile apps came online. So mobile apps came, they had all this native, like really nice functionality, pull to refresh and so forth. You couldn't do it in normal, just with links and forms on the web. The web always had this sort of clunky feel to it. And unfortunately, because the web hasn't really grown as a hypermedia system in the last decade, people have increasingly built web apps more like mobile apps and more like thick applications from that. They've abandoned that RESTful network architecture to use this data RPC style of architecture, which has advantages. You can build a richer client user experience, but has disadvantages too, which is you end up losing that really loose coupling between client and server that you get in a proper hypermedia driven RESTful system. But as luck would have it, or at least I would argue, htmx allows you to stay with this RESTful model in a really like powerful way. Improve the UX so you can have it can't do everything React can do. Can't do everything a single page application can do, but it can do a lot of it. Or it can do some amount of it. We can debate about where that line is exactly. But for many people, I think for many applications, it can be good enough and they can build a better user experience while still retaining this flexibility that we find in the RESTful approach to things. We can get that decoupling that we see in the RESTful approach to things. So just because we're almost out of time here, I just want to come really quick over to the actives. This is the htmx website, and there's an examples page. And I just want to show you really quickly an active search example. So htmx, the way it works is you pepper some attributes in that look a lot like, href and so forth, like the normal attributes. So this is an input. And what it's going to do is issue a post to the /search URL. And it's going to do that when an input event occurs. And then this is a little bit of code to debounce that, so that if you type some input into this input, and it'll wait 500 milliseconds before it sends the request in case you're typing a bunch of stuff. And then it's going to take this response that comes back in the form of HTML, and it's going to put it in the thing that has the ID search results. So this is a CSS selector. If we scroll down a little bit, you can see that that basically is targeting this T body. And so let me give a demo really quickly of it here. I'm going to type AE, and you can see that it issued a post request. It issued a post request and got back a bunch of table rows, and those table rows were inserted into the table below. And so this pattern is called active search. Google kind of made it famous back in the day. But this is how you implement that in HTMX. So a total of, I think, 4 attributes. And this indicator just says, show this thing while our request is in flight. But you can see that I can, continue typing, and it filters down as I type. And if I delete, it goes back and so forth. And you can see, like, it waits until I'm sort of done typing before it issues a request. And so it's issuing these post requests, getting back some data, and inserting that in the DOM. And that's staying within that original RESTful model. We're getting that decoupling of client and server that the RESTful model gives us at the network architecture level, because we're getting HTML back. We're not talking in terms of JSON. The client doesn't know anything about contacts. It doesn't know what these rows are. It just knows I'm getting back HTML. I'm inserting it into the DOM, and that's it. That's all I'm doing. And so we're maintaining that decoupled, that ability to decouple client and server that the RESTful network architecture gives us, while still having what I hope you would agree is better user experience than, for example, if this was just a form and you had to click submit and there was a big chunk, and then the scroll state got all messed up and there was a big flash and all that. So HTMX gives you this ability to build more sophisticated user interfaces while still retaining the decoupling that comes along with the network architecture decoupling of the RESTful network architecture. And so there's a bunch more examples that you can look at here at htmx.org/examples that kind of show the various things that can be achieved with HTMX. And then you can ask yourself, okay, can I achieve what I need to for my web application with patterns like this? And then you can, maybe you can choose this architecture, choose this network architecture for your next web application. Okay, Q&A.
Now we can raise our hands.
Yeah, now you can raise hands. Sorry.
No
I kept
worries.
raising my hand because I was gesticulating.
Any questions? Feel free to unmute yourself. Or if you're a little shy, you can type it out too.
Yeah, how can I see the chat? Is there a chat? I prefer chat. I always prefer chat. Where is there's chat? Okay, I'm in the chat. Excuse me.
No questions? I know, like the first one is always
It was
who wants to be
shockingly
the first
brilliant.
one?
Everyone's just stunned into silence by the by how amazing the talk was.
All right, John Michael. Oh, we can't hear you.
Oh, I can't hear you, buddy.
What about now?
Yep.
Yep.
Okay. Where do you think the htmx falls apart? Like,
htmx, it falls apart when you have to respond in a low latency situation to a lot of events. So like you can't do like a game. You can do an online like a turn-based game with htmx, but you can't do like a legitimate, even like a 2D game with htmx would be really hard. Although someone did Pong with it using sse, the sse
yeah,
extension, which was pretty
I,
funny.
I mean, I,
So
I did Flappy Bird and Agario, so
yeah, okay, so there you go. You did Flappy Bird. You did it. You know it. So I don't know. I think situations where you have like a lot of, there's an essay called When to Use Hypermedia, which maybe you've read, but I think when there's a lot of like really fiddly dependencies in the UI, like one change here has to update like 10 different things, and you can't just refresh that entire, there's no element that you can target that replaces everything. You have to be really careful about, replacing particular elements. That can get kind of dicey in HTMX. And so that's when you might want to look at a reactive situation. But if you're, a lot of web apps are just getting a form into a database, and like, that's kind of wheelhouse for HTMX. So I work on an app that's pretty sophisticated and uses HTMX like right at the edge of what I'm comfortable with, and hyperscript, the stupid scripting language I've got. And so I've seen the edge, but it's hard for me to give you like a hard definition of what it is.
yeah.
Flappy Bird guys here, awesome. You're not supposed to do that. It's like there's
Yeah,
another guy. There's another guy building a like a closure based spreadsheet, and I was like I specifically said not to build spreadsheets with HTMX.
Yeah, I'm just a crazy Virginia man
Yeah,
over here.
I like it.
Yeah. Feel like you got to do silly things every once in a while.
For sure, 100%.
Yeah,
Well,
I've yeah, go ahead.
no, go ahead.
I've found that especially with real time applications, I I tend to worry about bandwidth
Mm-hmm.
whenever I'm, but I don't know if a JSON API would be less bandwidth than a hypermedia based API.
Yeah, bandwidth is typically not the issue. It's usually latency. Latency worries me more with hypermedia systems than with hypermedia based approach than bandwidth. No, that's not always the case, but for the most part. Cool. HTMX and JSX. Hold on, I'm reading this. Is that a question? Like, should you use the two together?
Yeah.
Yeah, I've seen people use JSX server side as like a client templating library. I don't know it very well at all, so I'm in no position to say if it's a good one. But I mean, if you like it, I don't see why not. So that's fine by me.
Yeah.
Mixing H.
Sorry.
Go ahead.
Yeah, the advantage I found is that there are a lot of React components,
Mm,
and using it through JSX, it allows you to just use it as is. You don't need
yeah,
to hand build components, so you
yeah,
can just take in these React components, and it's like plug and play, so to say.
right.
So I thought that might be a good approach. Second thing is it because they're organized as components, they're easily
Hmm.
identifiable,
Yeah,
and you can and reusable.
sure.
So
Yeah.
I just read an art. I think there was some discussion on not Reddit, the Discord, and
Mm,
the general opinion was that you should use these templates.
hmm.
So I thought I'll just get your views on that.
Yeah, I don't have strong opinions on it. I've always used templates. I would be interested to try out JSX, and I agree there's a great ecosystem around it.
Yeah,
HTMX is very agnostic towards what you do on the back end. And
true.
so you do, I think this is one of the good things about HTMX is you can try a bunch of different approaches and people like a lot of different approaches. Some people really like HTML builders, like
Yeah,
in language syntax for building HTML. So OCaml I know has a really good one. I think it's called Dream. Um, and that's great. HTMX doesn't care. You produce HTML however you want to, and that's fine by us. So yeah. So I guess that's my take. Sounds good to me.
absolutely. Thanks.
Yeah. Don't you think that the hexagonal architecture fits perfectly into HTMX? One port for HTML and possibly additional ones for clients using JSON. I gotta admit, I don't totally understand the hexagonal architecture. I agree that, so I think maybe what you're getting at, the way I talk, I'm just old school. So the way I would talk about it is if you have a model view controller system on your server, then you can have an HTML API that works against that model, and then a JSON API that works against that model, and whatever else. And I guess those would be called ports. Again, I'm not super familiar with the hexagonal. I apologize. I'm just not super familiar with it. But the way I come at designing web applications is with this really. I programmed in Rails for over a decade and Java before that, and so I just have this very strong affinity for the model view controller approach. And then you have you basically have an API. I say API, but I just mean HTTP endpoints for your web app, and then separate endpoints for maybe your JSON API, and then maybe say a separate endpoints for some other API that's like used by mobile if you're using whatever, some proprietary format or maybe some binary format, and then all of that ends up going through this model, which is where you get your code reuse. So I don't know how that fits into the hexagonal architecture, but that's the way that I think about it. So I apologize for that. Rails mentioned. Yep, I'm an old Rails guy. I love Rails. The Java world needs Rails so badly. It's unbelievable. I can't believe no one's built it. It's crazy.
Yeah, I'd really like the code gen in Spring Boot. That'd be really nice.
Yeah, and just like, I mean, go look at the API for Active Record is like perfect. It's so well done. It's unbelievable. Like I've used a bunch of ORMs and I get from people, but man, it's got all the callbacks you want and like the life cycle hooks, and it's any idiot can use it, which is perfect for me because I'm an idiot. And I've never run into like something that clean and easy to use, and it's too bad.
Yeah, and it fits really nice with HTMX because you can,
Oh,
you know, easily
yeah.
separate things into different parts. And
Yep. Yeah, Rails, I think this is underappreciated about it. It really has a strong focus on MVC and like does a really good. I think they made a little bit of a mistake where they have controllers that return either JSON or HTML, like that ability to do content negotiation. I don't think that has worked out very well. But I think in general, what I've always done in my Rails apps is immediately split the JSON API out to its own set of URLs, and then it's its own thing. And then all the reuse is done through models and active record. And it's worked so well for the stuff I've done. Any recommendation for open source projects using HTMX? I heard about the to-do apps. Yeah, I don't know. Let's see here. We can go to, what do we got? htmx.org/webring. This has some sites that are done in HTMX. So you can come to the webring and play around. I've got like my Netscape Navigator, pick a random one. So there's the list of sites is here. There's also essays. An example. What was this? This was Open United, which is an open source project which ported from React to HTMX and saw some benefit. Like he talks about the benefits of that. This is a good presentation or a good essay to read. It's not really an essay; it's just sort of a summary of a Django shop that moved to HTMX from React, and sort of like what their experience was with it. And obviously, I mean, I wouldn't have it up if it weren't a good one. It was a really good one for them. They reduced their code size by a huge amount, and like, everything got better. And their application was very well set up for HTMX. I think that's like, this is maybe a best case scenario. But if your app is close to what they were doing, then, maybe it will be good for you as well. Yeah, so that is unfortunately a closed source application though. So I do like to-do apps though. I don't know why people are so hard on to-do apps. You don't have any to-dos in your life? Come on, man. By the way, thanks for your work on CG. It saved me a lot of time. Good. Well, I'm really glad to hear that. Yeah, code base is, yeah, that's awesome to hear. I really appreciate that, Milo. Like, HTMX is a small library. There's no financial benefit to it, unfortunately. I got for a while there when HTMX was like really getting super popular. Like here, I'll show you the graph. I laugh about this. Get star history. Let's see, not embed. No, that's not here. In 1 second. So Big Sky Software HTMX. So I can point to you exactly when stuff happened, like right there. The Primogen started covering HTMX, and it went like that. And like right about here, I started getting calls from or emails from venture capitalists like, hey, what's going on with HTMX? What are you thinking? Like, what are you going to do with it? And I was like, guys, if I could figure out a way how to make money with this thing, I would love to do it. But there's no way. It's such a dumb and simple idea that like, it is what it is. Like it's out there now. And so I derive my repayment for HTMX is hearing from people like Milo where like, oh, this really helps. Like, great. That is my payment. So I really appreciate hearing that.
You should
start. Oh. What's that?
I just said you should start collecting all the all the loves from people.
Yeah, I know. I really should. Like, it's so easy to get embittered too, because there are some people that say some mean stuff about it. But it's always great to hear. I stopped getting calls from the VCs, by the way. I think they figured out that I'm a lunatic, and so I'm not financially useful to them. So.
I mean, I bought a hoodie.
Yeah. Hey, there we go. Yeah. I buy a hoodie. You can buy the book, Hypermedia.systems. I mean, if you want, you can read it online for free too. But you're not going to get rich selling books. I'll tell you what. That's all right though. It's all good. There's the fun here is just the fun on Twitter, and hopefully HTMX is useful to people, and these things end up working out. So I'm happy with all that.
Okay, 2 more minutes.
2 more minutes.
Any questions?
Questions, comments? Go read gregbrain.dev if you haven't. Like, this is my funny essay on sort of how I think about software development. Some stuff in there that's not great, but I don't know. At this point, I'm just going to leave it alone. It is what it is. It's an artifact. Oh, if you want, what you could do is you can go to swag.htmx.org and you can buy, is it up here? Where is it? There's a bunch of junk here you can buy. Oh, God, did it not? I thought I made it. Oh, here we go. Yeah. There's now a grub shirt that says no on it, which is what you should be saying to people when they ask you for new features. No. So you can buy the grub shirt if you want.
What are you wearing today?
What am I wearing today?
Yeah.
I'm not wearing it. I'm wearing like a pull. I taught today, so I went in and lectured. So I'm wearing a collared shirt, like the late middle-aged boomer that I am. All right.
Alrighty.
All right, guys. Well, hey, thanks. I hope that was useful and interesting and you learned something, and I hope you find htmx useful.
Thank you, Carson.
Yep.
Appreciate
Thank
the
you so
talk.
much.
Yep. Cheers.
Thank you.
Thanks.